Hello everyone, and welcome to our 10.5 notes on angle relationships in circles. Today we're going to look at two different situations, two different theorems. The first theorem applies to whenever you have two different lines that are crossing on the interior of a circle at point E and creating some angles, and we'll look at those relationships in a second. So that's when they intersect on the interior. We're also going to look at a situation where you have two lines that are intersecting on the exterior of a circle, meaning at point C. All three of these situations have two lines intersecting outside of a circle. So let's first look at the interior. If two secants or chords, meaning that we know that a secant touches a circle, it's a line that touches the circle twice, and then a chord has both endpoints on the circle. So if you have two secants or two chords intersecting on the interior of a circle, then the measures of each of those angles formed is going to be half the sum of the measures of its intercepted arcs. So let's color code this and make this a little bit easier. If I wanted to find this purple angle AEC, we know that it's vertical to angle DEB. Those are going to be congruent angles. Those are vertical to each other. Their measures are going to be the same. Then whenever you have those two secants, let's go ahead and outline this a little bit. We have these two secants, or these in this picture, it's chords. Those yellow chords create intercepted arcs. So we have our arc on the left is A to C. We have our arc on the right is D to B. So if we want to find that purple angle, either of those purple angles, angle AEC is going to be equal to blue plus pink divided by 2. So let's write that out. Arc AC plus, because it says sum, over here it says the sum of the measures. So sum plus pink, D to B, divided by 2. Okay, so you add together blue and pink, you divide by 2, and that will give you the star angles. I could do the same thing if I wanted this heart angle AED. I would do the top arc plus the bottom arc divided by 2 would give me either of those heart angles as well. All right, so that is for an intersection on the interior. Now let's look at the intersection on the exterior. If you have three different situations, one is where you have a tangent crossing a secant. The next is where you have two tangents intersecting, which is where it forms the full circle. The major arc and the minor arc will add up to 360, and the last situation is where you have two secants. But either way, the theorem is the same. If you have any of these three situations where they intersect in the exterior of a circle, meaning that point of intersection is at point C on the outside of a circle, then the measure of the angle formed is half the difference. So the key word that changed here is now it changed to the word difference of the measures of its intercepted arcs. So how do I find this angle? This angle right here, angle C, every single time, you're going to say that angle C is going to be equal to the bigger intercepted arc, which in this picture would be A to D, minus the smaller divided by 2. So blue minus pink divided by 2. Same thing in this picture. Blue minus pink divided by 2. And then same thing on this one, blue minus pink divided by 2. Why do I have to do the bigger one minus the smaller one? Well, if you were to do the smaller one minus the bigger one, that would give you a negative angle measure, which we are not going to have as an answer. So how do I find angle C in this first situation? It's going to be my blue arc, which is arc AD, minus my pink arc, because it says difference, BD, divided by 2. And that is how you're going to get angle C in this first picture. Okay? In this next picture, let's see, angle C is going to be equal to major arc BAD minus minor arc BD, still divided by 2. So still pink minus blue divided by 2. And then on this last one, same thing, angle C is going to be equal to the blue arc AE, the bigger one, minus BD divided by 2. So you're always doing the bigger intercepted arc minus the smaller intercepted arc divided by 2. Okay. A silly way that helps me remember this is that whenever I have them that cross on the interior, whenever you have this interior intersection, it kind of looks like a plus symbol if you turn your head sideways. Whereas whenever you're looking at the circle as a whole, it looks like a plus symbol. Whereas if you're looking at this next one, every single one of these looks like a minus symbol. So like B to A looks like a minus symbol to me. So we're going to add the interiors together that intersect to find those angles. We're going to subtract. We're going to find the difference whenever they intersect on the outside of a circle. Okay, so we might jump around a little bit on a few of these problems, but these are just some practice problems to practice these ideas. So the first thing I want you to do is figure out, is this an intersection on the inside or on the outside of the circle? So this point of intersection is going to be happening on the exterior. So I'm going to make myself a note. This is an exterior intersection. Since it's exterior, we know that we're going to be subtracting the arcs. So let's go ahead and look at our, this is a secant. And so when we have that secant, we get the blue is 85. We get that the pink is 28, and we're trying to find our angle, which I'm going to color code to be in purple. That's this star angle right here. So how do I find x? X is going to be equal to 85 degrees minus, because we're going to be doing the difference, minus 28 degrees divided by 2. That's how we're going to find x. X is going to be equal to 85 minus 28 divided by 2. That's the blue arc minus the pink arc divided by 2. 85 minus 28 gives me 57, and when I divide that by 2, I get 28.5 degrees for x. X is 28.5 degrees. Okay, we're going to skip ahead a little bit. I want to go find one of the other types of intersections, which is happening on the interior. So let's make ourselves a note. This is going to be an interior intersection of these two chords, and so we're going to be adding those together. Okay, so let's go ahead and highlight those chords. I have a chord here, and I have a chord here, which is creating this angle x, which is also the same as this one right here. And then I have a left and a right. I have a left intersection at 100 on that arc, and then the right one is at 60. So how do I find this angle x? X is going to be equal to the blue arc, which is 100 degrees, plus the pink arc, which is 60 degrees, and that is going to be divided by 2 after I add them together. So what is 160 divided by 2? That gives me 80 degrees for this angle. 80 degrees is this angle. It is also this angle, because those are vertical. If you wanted to, you could very easily find that this angle is 100 now, and this angle is 100 as well. But because we wanted to know x, I'm going to use the left and the right arc, and I'm going to add them together and divide by 2. All right, let's do that again. Let's look at f. So how do I find, let's first look at where this point of intersection is. This point of intersection is happening on the interior. So remember, whenever we cross on the interior, we're going to be adding together those intercepted arcs. So I have my chords. I have this chord and this chord, and I'm trying to find this purple angle, x. So how do I find that? Well, we look at our intercepted arcs. So we have, here's my two chords, there's 45, and then there's 90. So how do I find x? Well, x is going to be equal to 46 degrees plus, because they intersect on the inside, 90 degrees divided by 2. So 90 plus 46 is going to give me 136, and I divide that by 2, and I get a 68-degree angle. And that does look like a 68-degree angle. It's a little bit less than 90, so that is a good answer. It is an acute angle. All right, let's keep going. Let's go to I. Let's skip ahead to I. I know that this is an exterior intersection, and so because this is exterior, I know that I'm going to be subtracting. I'm going to be subtracting my intercepted arcs and dividing by 2. Okay, so let's go ahead and color code it. We've got what kind of lines do we have here? Looks like we've got a secant line and another secant line. So that creates this angle on the exterior of this circle. How do I find that angle? We know that y is going to be equal to the big arc that gets intercepted, which is 110, minus the small arc that gets intercepted, which is 30. So 110 minus, because it's an exterior cross, 30 divided by 2. So we're going to do 110 minus 30. We're going to divide that by 2, and we're going to get a 40-degree angle at y. Does that make sense as an answer? Yes, it does, because that is an acute angle. Okay, so that is the direct presentation of the theorems. There are going to be some times where they provide the angle of intersection, and you have to find one of the arcs. So let me give you an example of what I'm talking about. On problem B, when you go to look at this problem, you already have the intersection. This point is the intersection of the interior, and you know that it is 47 degrees. So since it's crossing on the interior, I know that I'm going to be adding the arcs. But I'm missing an arc. I have the 50, but I don't have the x. So what we're going to do is we're still going to plug this into the exact same formula. So I'm going to take that angle, 47, and I'm going to set 47 equal to the sum of the arcs, so x plus 50 divided by 2. Okay, so now I'm missing an arc instead of missing an angle. So I'm going to have to do a little bit of extra algebra. How do I move the 2 to the other side? What is the opposite of dividing by 2? We're going to multiply by 2 on both sides. That is going to give us 94 is equal to x plus 50. Okay, so how do we get x by itself? We're going to subtract 50 from both sides. And when I subtract 50 from both sides, what is that going to leave me? For x, that is going to leave me 44 degrees. 94 minus 50 is going to give me 44 degrees. Does that make sense in terms of what that arc should measure? Does this look like a 44-degree arc? It does. That is a minor arc, so I know that I got a good answer. You could always go back and check it by doing 50 plus 44 and then divide by 2, and you will get 47. So you're just having to work backwards on this problem. Okay, same thing here. I have an exterior point of intersection, but I'm given this angle. I know it's going to be a subtraction. I'm given this angle. And so that angle, 50, is going to be equal to the 2 arcs that get intercepted by these secant lines. So what are those 2 arcs? 130, and then I'm looking for the other one. I'm looking for the smaller arc. So 50 is going to be equal to 130 minus x, because this is crossing on the outside, divided by 2. So again, I'm looking for one of my arcs here. So how do I get the 2 to the other side? I multiply by 2 on both sides. That gives me 100 equals 130 minus x. When you subtract 130 from both sides, you're going to get negative 30 equals negative x. That's negative 1x, so you divide by negative 1 on both sides, and you end up getting positive 30. Does that look like a 30-degree minor arc? It does. So that is a good answer. I found the measure of the arc here. All right, let's do that again. On this problem, again, we have an exterior intersection. So as soon as I see exterior, I'm going to make a note about that. I know I'm going to be subtracting the arcs. What I'm doing here is I have a tangent line, it looks like. It appears to be tangent, and a secant line. And so I have the 95, I have one of the arcs, but I'm looking for the smaller arc, z, but I already have the 20. So what I'm going to do is I'm going to take that 20, and I'm going to set it equal to the blue arc, 95, minus, because it's difference, the smaller arc z, and I'm going to divide that by 2. So I multiply by 2 on both sides, and I get 40 equals 95 minus z. So when I do 40 minus 95, that is going to give me a negative number, which is totally fine. I get negative 55 equals negative z. So what is z going to be? It's going to be equal to positive 55. Does that look like a 55-degree arc? Is that a good answer? It is. The measure of that arc is 55 degrees. Okay, so we have a few more examples. I'm going to do 2 more where you have to work backwards because these are a little bit more challenging. Where do these cross? Where is the intersection of these 2 chords? The intersection of these 2 chords is on the interior, so I'm going to go ahead and make a note. That is an interior intersection, so I'm going to add the arcs together. Here are my chords. I have 2 chords crossing. And what are my intercepted arcs? We have x and we have the 30. So I can take that 35, that angle right here, this 35 degree, is going to be equal to blue plus pink, so blue plus, because they cross the inside, divided by 2. Okay, so I'm looking for the measure of an arc. So I'm going to multiply by 2 on both sides. I get 70 equals x plus 30. How do I get x by itself? I'm going to subtract 30 from both sides, which makes this a 45 degree. Let's go ahead and color code that. That is going to be, the measure of that arc is going to be 45 degrees. So x is going to be 45 degree arc. Does that look like a minor arc, 45 degrees? It does. And if you did 45 plus 30, you would get, whenever you go back to add this together, oh, y'all, not 45. I'm so sorry. Let's see, this is why you'd always check yourself before you wreck yourself. This should be 40. Because whenever you do 70 and you do minus 30, you get 40. And you should always check yourself because watch what happens. 40 plus 30 is 70, and 70 divided by 2 is 35. So it always helps to go back and check. You can see I just needed to do that as well. Okay, so now we have an exterior intersection again, an intersection, y'all. We have an exterior intersection. So we have an exterior, so we're gonna end up subtracting my arcs. So let's look at this real fast. This appears to be tangent. This one appears to be tangent. And so whenever we have 2 tangent line, that's gonna create the blue part of the circle, and then you're going to have the pink part of the circle. And together those make a full circle, which is 360 degrees. But here we are looking for x, so we're actually looking for our exterior. The problem is I don't know what blue is. But since I know that this is 132, together these two should add up to 100 or 360. So I'm going to do 360 minus 132 should give me my blue amount. So let's find that real quick. There was just an extra step on this problem. That gives me 228 degrees. 228. Well, why does that help me? Because I want to find this exterior angle. So the exterior angle x is going to be equal to the big arc, which is 228, minus the small arc, which is 132. Again, it's minus because I'm doing the difference, and I divide by 2. So what is 228 minus 132? It's 96. That divided by 2 is going to give me 48 degrees for this exterior angle. Does that look like a 48-degree angle? Does that make sense as an answer? It does. And you could check it again by plugging it back in, and you will always get 48. All right, so what we have on the back is we have some practice problems of these theorems. We have some lines that are intersecting inside the circle where you add, and you have some lines that are intersecting outside the circle where you subtract the intercepted arcs. So practice that, and then we will check that tomorrow.